Hi guys, so here we have the SAP-1 simulation. So here we have the address 00 for instruction load 11. So the active pins for this will be the EP and LM. So EP meaning enable program counter, and then LM load uh, memory address register. So the value of 00 will go to input and more, then it will convert its 4 bits into 8 bits, which will be the value of 11. As you can see, load LDA 11. Then at T2, the active pin will be CP or the program counter, and the address will be incremented by 1. Incremented, so there. At T3, the active pins will be CE of the 16 by 8 RAM and LI of the load instruction register. So as you can see, the 00, the 8-bit value goes to the instruction register, and then the higher nibble goes to the controller sequencer for decoding. For T4, the active pins will be enable instruction register and the LM for the input and mar. So the lower nibble will go to the W bus and then go to the input and mar. Then give its 8-bit value. At T5, since we're loading 11, will have active pins at CE and then LA from the accumulator. So from the 16 by 8 RAM, the value would go through the W bus and then be inputted into our accumulator. At T6, as we can see, there are no active pins. At T1, we'll have another address, the 001, and then the add 10. So we'll have the EP and LM activated, enable program counter, and the LM from the input and mar. As we can see, the value 001 from the program counter moved to the input and mar, and then gave its 8-bit value. At T2, increment the 001 into 2 in its decimal value. And the active pin is CP. At T3, so the active pins are CE from the 16 by 8 RAM and LI from the instruction register. So the value would go through the W bus and overwrite the value in instruction register. Then the higher nibble, as you can see from T3, the higher nibble went down to the controller. And at T4, the active pins will be EI and LM from the input and mar. So the lower nibble will go to the LM input and mar and overwrite the value there, going to the W bus. So it will always give the 8-bit value if it's 4-bit in T4. And then at T5, since we have an operand here, the add 10, the activated pins will be CE from the 16 by 8 RAM into the LB or B register, load B register. At T6, since the activated pins is EU and LA, since it's 0, and then we'll add the value of 0110 to 0111, which is 6 plus 7 equals 13. 13 in decimal value. So you'll see there. Then it will move to the W bus through the accumulator, since the active pins is EU and LA. Boom. Then at T1, we'll have the address 0010 at the program counter, and the active pins will be EP and LM. The address 0010 will go through the W bus into the input and more and overwrite the content there. Then give its 8-bit value. So at T2, the value 0010 will be incremented. So 0010 rather. So 011 is 3 in its decimal value. So for T3, the activated pins will be CE and LI. CE from the 16 by 8 RAM to the instruction register via the W bus. So as you can see, it overwrite the content in the instruction register, and at the same time, the higher nibble went to the controller sequencer for decoding. At T4, from the instruction register, we have the EI, enable instruction register, and then the value of that will be going to the input at MAR, since the active pin is LM via W bus. The lower nibble would be put there and there. So here at T5, we have the CE and LB pin. So from the value of the RAM, we'll go to the B register. At T6, we have the SU-EU pin and the LA active. So just subtract the value of the two. Boom. Here, there. Then they will go to the accumulator. Then there at T1, we have the out EP and LM pin active. Give the 8-bit digit. And T2 increment. T3 CE to the LI or instruction register. Boom. Then the higher neighbor rather goes to the control sequencer. And at T4, of course, since we already at out, we'll have the EA and the LO pin. So the content from the accumulator to the output register. Then we'll display the 10 value or the decimal value of this lower. At T6, no active pins. And at halt, we have the EP and LM active at T1. So we have 0100 going to the input and MAR, override, give the 8-bit value. Then T to increment the program counter from the CP, then T3, there, CE to LI, and then the higher nibble will go there. Then that's it. Computer is halted. Thank you for watching.